Greetings, my name is Ryan Nix. I'm a solutions architect for Amazon Web Services. I'd like to take a moment and talk to you about OpenShift on AWS, app modernization workloads, the new kid on the block, OpenShift Virtualization, and some ideas around shared storage options for both your container as well as your virtual machine workloads. OpenShift has been available on AWS for quite a long time now. Historically, customers would deploy OpenShift on AWS utilizing a self-managed version of OpenShift. This would typically be something like the OpenShift Container Platform, or OCP, where customers would implement this into their own AWS account. So they would be responsible for install, configuration, and then again the day-to-day operational management. So high degree of customization, high degree of control, but you as the customer responsible for everything that is OpenShift. In recent years, we've seen customers shift away from wanting to do everything themselves and rather gravitate towards focusing on doing what is critical to the business instead of maintaining OpenShift. Hence, we've seen this shift towards a managed version of OpenShift. This would be the Red Hat OpenShift service on AWS, or ROSA. ROSA is a fully managed version of OpenShift. It has a Red Hat SRE team in the background making sure that OpenShift is constantly available to you, and it is a joint supported platform where customers have choice, where they can reach out to either Red Hat or to AWS for their support requirements, but managed by Red Hat in the background. Whether you're going managed because you want to focus your resources on things that are other more business strategic to you, or alternatively you want something like a self-managed implementation where you've got a high degree of customization and a high degree of granular control over OpenShift, we've got choices for you. Both OpenShift implementations are available directly through Red Hat as well as through the AWS marketplace, and ROSA is directly integrated into the AWS console as a native service. You'll find it underneath the containers section. When we look at OpenShift on AWS, a recent trend is to take the control plane that is OpenShift, that is the master nodes, the API endpoints, and shift that out of the customer account into a hosted control plane configuration. So historically, all of this control plane configuration would end up inside the customer's account. Now with hosted control plane, we see the control plane existing in a service team controlled account outside of the customer, which means that there are less failure points within the customer environment, and there is a cost benefit because the underlying AWS resources, specifically the EC2 instances and the EBS directly attached volumes, are not incurring cost within the customer account. So what does that leave within the customer account? Whether you're going for managed OpenShift ROSA or whether you're going for self-managed OCP, in both cases you end up with the compute or the worker nodes still existing in the customer's account and the attached EBS volumes to those. So whether this is a customer that is doing app modernization and they're building containerized workloads, and those workloads are going to manifest as container apps running on top of their worker nodes here. So we'll typically see apps running inside containers and running on top of the EC2 instances that are provisioned as worker nodes. What we do see as a recent trend is customers taking advantage of different EC2 types. So for example, we may have customers who are taking advantage of AI/ML workloads that are using GPU-backed instance types, and you may see another layer of compute, another machine pool of AWS EC2 instances that are GPU capable coming in there. I want to shift focus onto something different. it has become very popular to take advantage of virtualization on top of OpenShift. So what this means is I can deploy another set of EC2 instances into my OpenShift cluster and utilize these not for containerized application workloads, but instead take advantage of OpenShift virtualization and deploy virtual machine workloads directly into my OpenShift environment. Now you're probably thinking, why would I take advantage of this when I could just run VMs and something else? Well, many customers are sitting with two dilemmas. The first is, I've started a modernization journey, and I've started that journey of taking my traditional applications and refactoring them and replatforming them into a modernized container strategy. But I can't do that with my entire empire overnight. What I can do is I can take my virtual machines that form part of that legacy technical debt footprint, and I can bring those into OpenShift. I can run those inside OpenShift alongside my container workloads, and then gradually have my app developers convert the workloads within those virtual machines into my container future, utilizing the toolset that OpenShift provides. Now, the first benefit of this is this gives my customers virtual machines a degree of portability. If they're inside OpenShift virtualization, they've got the exact same state whether they are on premises or on the cloud or anywhere within the customer's hybrid estate. So I can very, very easily move workloads around within OpenShift. I get that benefit of the OpenShift portability, very similar to what I get with container workloads running in OpenShift in a hybrid context. The other benefit is I'm seeing more and more customers who are looking at a data center exit strategy. They need to move out of their data center. They're being mandated to move into their cloud estate. For their applications that are containerized, for a long time this has been, let's lift and shift those containers from something like OCP on premises into managed OpenShift and AWS. Customers can now do the same thing with their virtual machine estate. I can pick up the virtual machines, and it doesn't necessarily have to be an OpenShift virtualization to start. It's very common to see things like customers running VMware workloads where they lift and shift those VMware workloads into OpenShift, and then they've got portability to move them around, as well as take advantage of having those run side by side with container workloads and accelerate the conversion from VMs to a container-based future for those application workloads. With both app modernization customers and virtual machine customers, we have a requirement for shared storage. Let's take a moment and dig into the shared storage side of things. This is over and above the storage that is directly attached to my EC2 instances or to my compute layer here. When we zoom out of the OpenShift environment and we have a look here, we've got the compute layer, the worker nodes. These will have directly attached local storage in the form of Amazon's Elastic Block Store or EBS volumes. The challenge with EBS volumes is they are cost effective, they're performant, they are great for storing things on. However, my storage is isolated within an AWS availability zone, which means that if a workload is running in this availability zone and OpenShift makes a decision to move that workload to another compute node, another worker node, there is the possibility that an app workload could move to a different availability zone and lose interaction with the storage that was directly attached to it. So this doesn't work for every single workload. There are going to be container workloads, there are going to be parts of my configuration where I want to take advantage of shared storage, storage that is available to the OpenShift cluster that crosses all availability zones, and my application workloads can interact with all of those. Typically, shared storage could be a collection of things. On AWS, we could utilize Amazon's Elastic file system. We could take advantage of FSx NetApp Ontap, which is highly performant and highly resilient. There are third-party options in the form of a variety of collections over there. But we can take those shared storage options, and we can put them into two buckets: a traditional approach to shared storage, or something slightly different. Let's take a moment and have a look at a more traditional shared storage environment. So what we would typically see in a shared storage environment is we would deploy some form of compute. These would be EC2 instances, and we would put them into each availability zone and make sure that I have an additional layer of compute node over here. Then what I would do is I would attach Amazon's EBS volumes to those instances directly. Then the software that we would deploy onto the storage system, if that was a third-party storage solution, it would then be responsible for making sure that this is presented to the OpenShift cluster, and that replication, whatever I change on this storage environment, is then duplicated to this storage environment and is duplicated to that storage environment to cater for resilience. The idea here is that I have storage available in each availability zone, that it is replicated for resilience, and that whatever storage solution software we're utilizing, it is presented to the OpenShift cluster. And when my application workloads, whether those are container workloads or whether those are virtual machines, those have the ability to move around with ease, and I don't have to worry about this. The challenge with a traditional model is, firstly, I have a fairly significant infrastructure footprint that exists in the customer's AWS account. So I've got EC2 instances, I've got EBS volumes, and those are triplicated across my availability zones in order to cater for resilience. The next challenge that I have is any write that I make into the one location is very likely going to be replicated to the others, which means not only am I triplicating the data, but every time I make a change to that data, I'm likely to see inter-availability zone data transfer manifesting within the environment. These translate to expenses within the account, within the architecture, that maybe I don't want to deal with. Let's go take a moment and zoom out from this and have a look at a slightly different approach. So over here, what we've done is we've taken out our traditional shared storage option, and we've brought in Amazon's FSx NetApp Ontap. And FSx NetApp Ontap is a AWS native service. It's fully managed. And what we've done in the background is we've taken the compute storage nodes, we've taken the EBS volumes that would live in the customer's account that would be duplicated or triplicated, and we've shifted that out of the customer's account and we've put it in the background in a service team account. So we've created the same resilience model, the same benefits, the same data protection, but we've built it as a managed service outside of the customer's account. Customer still gets all of those benefits. They still get a multi-availability zone capable shared storage platform, a multi-protocol storage platform. It caters for both file and block and is an enterprise grade solution. The benefit here is A, it's not inside the customer's account, so we get that cost reduction, and B, it's a fully managed first-party native AWS service as opposed to potentially a third-party solution. Now, FSx NetApp Ontap, what does exist in the customer's account is we very simply go and create a endpoint in the availability zone, and this allows whatever is in the customer's account to reach out and interact with the actual storage that we've created in that background service team account. This is very similar to many other AWS services where the magic happens elsewhere and there's just a connection point. From an OpenShift standpoint, how we stitch OpenShift to FSx is we've created a CSI driver as well as a Trident driver. So inside my OpenShift cluster, I'm deploying a CSI driver, and then that CSI driver wraps around the Trident driver. This allows OpenShift to interact with my shared storage and present that shared storage to my workloads running inside OpenShift. It also allows me to control through that driver and that operator framework my storage. So I can create storage classes, I can actually go and create shared volumes, I can create volume claims for my workloads. This means that Amazon's FSx NetApp Ontap can not only provide value to customers who are in an app modernization space and are utilizing container workloads in OpenShift, but that can now take the same performative value from FSx NetApp Ontap and apply it to their virtual machine workloads. So whether you're running VMs using OpenShift Virtualization, or you're using OpenShift as a app modernization container workload resource, you can utilize FSx to cater for the storage for both of those. This gives customers a huge amount of flexibility, the same resilience, the same performance benefits that they're looking for, but without the additional costs, without the additional complexity, all coming from combining that native AWS service experience with a driver set that can be integrated into OpenShift and take advantage of both sides of the world. So if you are entertaining app modernization, or if you're looking at OpenShift virtualization on top of OpenShift, absolutely consider scratching around with the CSI driver for FSx NetApp Ontap. That takes us through OpenShift on AWS, app modernization and virtualization workloads, and then of course the benefits of utilizing FSx NetApp Ontap as a first-party native AWS service that is both managed as well as a trusted solution to give you peace of mind whether you are utilizing it for app modernization container workloads, or alternatively for virtual machine workloads running in OpenShift Virtualization. Thank you very much for joining me, and please don't hesitate to reach out to any of your supporting account teams via AWS, Red Hat or NetApp if you would like to dive deeper into any of these topics or discussions. Looking forward to chatting to you in the future.